Okay, so trig is one of the best topics of maths, apart from calculus. So hopefully you remember some of the things from Pythagoras that we've just done. The difference between Pythagoras and trig is that now we're dealing with not just lengths in the right angle triangle, but lengths and an angle. Now, the angle we're going to call theta, this little circle with a line through it. It's a Greek alphabet letter, so we call that theta. The hypotenuse is still the same, opposite the right angle, but now we focus on this angle and we say, well, the side that's opposite the angle that's in question, this angle, we call that the, believe it or not, the opposite side. And the one that's left over, the one that's next to the angle, that's called the adjacent side. And we should have our three beautiful rules. The sine theta is opposite over hypotenuse, cos theta is adjacent over hypotenuse, and tan theta is opposite over adjacent. So those should be written down somewhere lovingly in your book, because we're going to keep referring to them and use them all the time. We'll just skip through some of this stuff. So that's the SOHCAHTOA that helps us remember the three rules if it works for you. And those three rules are only for right angle triangles. Now, the three possible examples that we have. So example one, could be any triangle that a right angle triangle. We've got our angle here that we are interested in. And so I think the first thing when we label, the first thing we have to do is label the sides. And the first side that I always label is the hypotenuse, because it's opposite the right angle. It's always going to be there, and bang, we put the H. And then we look at the angle that we're focused on, the non-right angle angle. And that will be the side that's opposite that. We call that our opposite side, okay? And so our leftover side, we've got the opposite, we've got the hypotenuse, so the leftover one here has to be the adjacent. And now we want to know, well, which out of those bits of information is the useful? And we need to find, or we want to find x. We have hypotenuse, the information here, so those two stay, whereas the adjacent, that's useless to us, so that has to go. We then look at those three rules that we just wrote down, and we see which is the only rule that uses O and H, and it is clearly the sine rule. Once we have our rule, we want to substitute our information in. So remember, theta represents our angle, so it's going to be sine 48 equals the O. We're going to replace with the x over here, and the hypotenuse is 23. So it ends up being sine 48 equals x over 23. I don't want x divided by 23, so to get rid of a divide, we need to times, okay? So we times both sides by 23. The whole reason, remember, we times by 23 here in the first place was to get rid of that divide. So that cancels out, and we're left with x equals 23 times sine 48. We go to the calculator, making sure it's in degrees, and that's the answer we get. It's less than 23, which is the hypotenuse, so we know that that's a pretty good, sensible answer. So that's the first example. So I hope you've got that written down. Have example one, and just make sure that you have all of this written here. Okay, so have it nice and clear, because you will have to keep going back and looking at that in your book. You'll find you'll get these steps down, so you don't need to write them down all the time, or in fact once, because you'll remember them. So if we look at example two, again, it's a different triangle, still a right angle. You think the only thing that's changed is the numbers, so let's go through. So we label the sides. Hypotenuse, here we go, opposite the right angle, always the easiest to find. We label. The angle that's in question here, that's not the right angle, that means opposite that is the opposite side, which means the leftover side is adjacent. And I'm hoping you're feeling comfortable with labeling the sides by now. We think about which information is useful to us. So once again, I want to find the hypotenuse. I have this opposite information, and so again, the adjacent is useless to us, so that goes. And we know from last time that that means the only rule that uses O and H is our sine rule. We're getting pretty good at this now. We know that theta is the angle, so it's going to be, when we substitute our information, it's going to be sine of 27 equals, and this is where it's a little bit different, because our O this time is 14, and our unknown is down the bottom this time, downstairs, okay? So we want to now get rid of this x from downstairs. We want it to be upstairs. So how do we solve that? Well, to get rid of a divide, we have to times. And remember, those will cancel. I've now got x times sine 27, so I need to get rid of this times. And to get rid of a times, we divide, and they cancel now. So I'm just left with x equals 14 divided by sine 27. Now what I tend to do is I'm a little bit naughty, and so what I do is we say, well, when the unknown is downstairs, we just switch. We do the switcheroo. Okay, so I don't actually have this line in at all, this second line. I get rid of that, and I just go, unknown is downstairs, you switch, and we get to that. And we pop that in our calculator and we're good to go. Okay, so you're going to have, so far we've got two different examples. The first one, when the unknown is upstairs, and that's what we looked at previously, so go back and look at that, and that's where you get rid of the divide by timesing. And when the unknown is downstairs, we do the switcheroo. So that's where we're dealt with an unknown length. What do you think is the last example? You are correct. It is when we have an unknown angle. But the same method is applicable. So the first thing we're going to do, once again, is label our sides. The hypotenuse hasn't changed. It's still opposite my right angle. I look at the angle that I'm interested in, and in this case, it's this one here. And so, lo and behold, the side that's opposite that angle is still called the opposite side, and the leftover is the adjacent. In this case, our useful information is going to be the opposite because it's got a value. The adjacent has a value, so this time hypotenuse is useless, and that gets the flick. We look at our rules, and we want to see which rule uses O and A, and it is only the tan rule. So we put our information in, substitute our information. This time we don't know what theta is, so we have to leave it as tan theta. The O is 52 and the A is 77. So it's not a guess of is it 52 over 77 or 77 over 52. You have to follow what the rule says. So it says O, so opposite over adjacent, so it has to be 52 over 71. We write that down, and now we go, well, how do I get rid of this tan? Because I don't want tan, I just want theta. So you need to look at your calculator, and just above your tan button you will see a little tan to the -1, and that's what we want to use. Now in order to use that, you have to press Shift Tan, okay, because it's upstairs. So push your Shift button and we go Shift Tan bracket 52 divided by 77, close your bracket, and you should get an answer of 34 degrees. Now those are the only 3 types of examples that you can get. Obviously, if this, instead of this 77 being here, if it was on the hypotenuse, well, instead of pressing Shift Tan, opposite hypotenuse, you would have pressed Shift Sin. And if you were using just A and H, then you'd be pressing Shift Cos. So it all comes back to make sure you label the triangle and make sure you've got the right rule, and then you look at where is your unknown, and you look at these 3 examples and follow one or the other, the one that looks most like your problem. Okay, so hopefully that sets you up and you can nail all of the trig questions that come your way for right angle, because it's only one of these 3 questions. Good luck.